package or the app bundles context. And the reason that that's significant is because, again, the payload you're using for your red team mount will not have any TCC accesses unless you have a bypass or an exploit. But there's a good chance terminal has been granted some level of access. So then you're migrating your operating context from your payload over to terminal, which there's probably a good chance that you would have access. And then you can run the checks that I mentioned before to see what accesses you have and then access those directories safely. Some other interesting aspects of mdfind is you can search for like files with different keywords in it. And what's kind of cool about that is you can not only search like the file name, you can actually search the contents of the file, the KMD item text content value, which is the string content of the file. So like you can use these types of searches to look for like files with passwords or tokens or keys. You can also look for recently created or modified files. You can search for AWS keys by looking for that AKIA identifier. Lots of different uses of mdfind. And I also have versions on my Spotlight enumeration kit site, API versions of these. Like if you don't want to run the mdfind command, you can run the mdquery version that's using API calls. So a few other interesting commands. You can remove quarantine attributes. Of course, you can do it with the XATTR binary, but you can also do it with cat and curl. Like in each case, you feed it the file that has the quarantine attributes and you write it out to a new file. All the content's the same, but the quarantine attribute is stripped. Another thing that was kind of interesting, like another way to display or get file contents is you can use md import, which is used to like import Spotlight plugins. But you feed it these parameters and a path to a file, and you can see it pointing there to the KMD item text content, which is the contents of the file. So it's another way of like catting out file contents. You can also dump clipboard contents using pbcopy, or you can use OSAScript. And essentially, like you think about, a lot of users might use things like KeyPass or like password managers where you're copying passwords and pasting it. And so like you might be able to grab that content using pbcopy or OSAScript. You can check if your host is in a VM using that sysctl, or you can even run the arch binary. ARCH will also give you the architecture. And lastly, you can check if your screen is locked using that ioreg command there. And I've used this in the past before where if you're doing, like I was doing something with Chrome where windows were closing and opening and I didn't want the user to see it. And so I just kind of ran this command periodically and the idle check command below as well, and kind of waited for the screen to be locked and make sure the idle time was high, meaning the user was away. And then you can run, like I would run my technique, which would open and close a few windows for a few seconds and then move on. So a few other interesting data sources as well. When it comes to TextEdit documents, if you have like, and I've done this before where I have like TextEdit open and I'm like typing in it and I might not save it and I'm just kind of keeping it as like a running list. If you're doing that and you don't save it, the contents of that TextEdit document can be grabbed because it's written temporarily to disk as a RTF. It's not protected by TCC, so you can just like browse to that directory and dump it out and look at the contents of that. Same with sticky notes. I've never really used sticky notes, but I think it's kind of cool. Like you can just have sticky notes on your computer where you have little notes, like a virtual version of sticky notes. Same thing there. If you have one open and you're typing in it, you can just grab the contents of that because it's also an RTF file and it's not protected by TCC. Another thing that's interesting is Firefox. One thing we found in a past operation was looking at how Firefox stored its cookies. And unlike Chrome, which has encryption and safe storage key and stuff, like Firefox just had the cookie in plain value. And so like we were able to download the cookies.sqlite file from like a target machine, port it over to an attacker machine, delete the SQLite TAC-WAL file on our attacker machine, close and reopen Firefox, and we were logged in as like that user into all the sites that the cookies still work for. So I thought that was pretty interesting. And now Chris is going to come in and talk about some additional living off the land binaries that are of interest.
So the first tool or lolbin that I want to talk about is dns-sd. This is a tool used to test the multicast DNS discovery protocol, or otherwise known as Bonjour. This is a protocol that is used by a lot of multimedia and home devices to broadcast services that are available. You'll see this whenever you want to stream video from your mobile phone to like your TV. Your TV is using MDNS to broadcast that service so that your phone can see it. And so this is a really cool protocol because it's quite noisy. A lot of devices use it on local links, and so you'll see it on the network. And it's very easy to blend in if you wanted to broadcast a service. It doesn't look abnormal particularly. But also, you're able to listen and kind of get information about what services are available, and i.e. what ports are available. So you can do things like listen for SSH or listen for HTTP or web. You can listen for remote screen sharing, which will help you identify other macOS endpoints on the environment, at least the ones that have remote screen sharing enabled. You can also use AirTunes, which is kind of neat because you'll identify both Mac endpoints and iOS devices. And so there are a lot of different services you can listen for and use to identify potential avenues for lateral movement or further attacks in an environment. If you want to find other bonjour or MDNS strings, you can look at the link at the bottom of the slide. There's a long list of strings you can use to identify services that are available and maybe find out what kind of device is on the network. So the next lolbin I want to talk about is osacompile. I listed this under code execution, but technically it's not. But you can use it to build an app bundle or some resulting file to then later execute. So osacompile is used to compile AppleScript or JXA, JavaScript for automation, into what's known as a script or .scpt or application bundle. So really the resulting application bundle looks pretty identical to other app bundles you've seen used legitimately or in the wild, except for a few differences or one or two differences, and that's in the directory structure. So if you look in the macOS folder, you'll see that there's a main applet binary. This is the binary that runs your JXA code, and that's always going to be called applet for whatever reason. There's also a resources and then scripts subdirectory. And within that scripts folder, there is a main.scpt file. This is a file that contains either the AppleScript or JXA plain source. It's not obfuscated or encrypted in any way. So if you're a SOC analyst or IR person, you can recover source for a payload like this in that file. And attackers, you probably want to obfuscate or encrypt your JXA payload in some way. Ideally, I would use this within a post or pre-install script. I would just have the package installer install the JXA file on disk somewhere and then use osacompile in the post install to compile it. Now, optionally, you can change the icon with the .icns, or you can add the LSUI element key in the info plist to hide the application from the doc and the UI. All right, so the next lolbin I want to talk about is LLDB, and specifically LLDB plugins. I'm sure most of you already are familiar with LLDB. It's the native debugging tool for macOS. Not the greatest thing in the world. It's command line based. Doesn't have a nice UI like Winbag, but it does have plugins. And so you can automate some of the functionality like attaching to processes, inspecting variables, inspecting areas of memory or registers. You can automate some of that with LLDB plugins. So what's nice about LLDB plugins is they have a dedicated, Python package for it. So if you go to the website and download one of their templates, you can see that they give you a skeleton plugin to work with. But you can also just use a vanilla Python file. It can be anything. As long as it can run in Python 3, it should be fine. But essentially, you want to install a plugin by creating a .lldb init file in the user's home directory, save your Python file or Python payload somewhere on disk or somewhere accessible. And then in that LLDB init file, you'll want to write the command script import and then the path to your Python payload. And so now whenever the user opens up LLDB, it'll load and execute your Python code. Now, the caveat with this is that you probably want to have, if you're using like a malware payload, you'll probably want to have the malware launch or execute in a background thread, because if there are blocking calls in your Python payload, it will halt the LLDB process and wait for your function to finish. And so if the user is using Xcode and they hit that play button to debug their app, the LLDB debugger will eventually time out because it's not able to connect to the LLDB server because of your plugin. And so to be a little bit more stealthy, you want to run your Python code in a background thread. So the next lolbin that I'm going to talk about is AUVal tool and audio unit plugins. If you are into music production or you're a DJ, you like to create music, you're probably familiar with these. They're used for a lot of different things in audio production. You can add sound effects to instruments. You can create synthesizers. You can do a lot of interesting things with audio unit plugins. And they're typically used in software like GarageBand, Audacity, or Logic Pro. But at the core of it, they are just bundle files. And so if you go in Xcode and create a new project, you'll see in the list of templates that bundle is an option. So if you create a bundle project, you'll notice it's a pretty empty project. You'll have like an info P list, and that's kind of it. You'll also want to create an Objective-C source file, a main.m or something in there to host your malicious code. In that source file, you'll want to define a function called a module initializer. And so this is just a function that is executed whenever the bundle is loaded into AUVal tool. And so that's where you want to have your malicious logic. Also in the info P list, you'll have to add a few special keys. These key values are arbitrary. They don't necessarily have to be something specific, but you do need to have these keys set in the info P list. This is how AUVal essentially parses your audio plugin. So you'll set the manufacturer, the name, the subtype, and the type. Once all that's done, you can build your project and then save your plugin in library audio plugins and components. You'll save it there, and then to invoke it or execute your code, you'll run AUVal tool with the tag A flag. This will iterate through all the native system plugins and then also the third-party ones and test each of those. Then once it hits your plugin, it'll execute your code. You can also run it with the tag V flag and pass in the type, subtype, and manufacturer arguments to load just your plugin. It's a really awesome tool. Definitely recommend playing around with it. So the last lolbin that I'll talk about is safaridriver. This is a binary that is used on macOS to start the Selenium WebDriver API over an HTTP web server. So the first time you run the binary, you actually need to have sudo or root privileges and then pass in the enable flag on the command line. This will configure it or configure safaridriver for other sessions and then disable the requirement for authentication. Now, once the Selenium WebDriver API is available, essentially it's just a web server that is listening on port 80. But once it's available, you can use any number of languages that support Selenium or have Selenium packages to interact with that API. My personal favorite is Rust. And then you can use those APIs to facilitate your C2 traffic or your traffic to download second stage malware. Now, the caveat with this is that once you start interacting with Selenium, it doesn't actually hide the browser. The browser window actually comes to the front of the desktop in front of all the applications, and it's visible in the dock. And so at minimum, you can minimize the window through the Selenium API. It doesn't hide it from the dock, but at least it's not in the user's face. Also, it's probably better for short-term or second-stage malware downloads rather than long-term C2 because the app is going to be up and running and open. And so the user may see it and say, hey, I didn't actually open this application, and they'll close it. And then they'll see a prompt that says, hey, do you want to end the session? And that looks kind of suspicious if they didn't start the driver session themselves. And so that's just something to keep in mind when using it, but it is pretty useful for making web requests through the browser and having, your C2 comms go through the browser, which it looks more legitimate.
Awesome. And so here's some references for some of the items we pulled. Just for additional information, you can look there. And thank you all for your time. Feel free to reach out if you have any questions and want to talk more.